Welcome back to B-Spice. In this session, we'll focus on compressor. In fact, one of our viewers requested to present on gas turbine. Yes, of course, I already prepared a good, beautiful video on this. I'll upload this after this compressor session. Yeah, because I thought it's appropriate to first learn about the compressor. Okay. I'll also take this as an opportunity to thank you all for the support rendered for this anti-surge control system. It was well received, and I hope to receive the same sort of support for this compressor session also, followed by the gas turbine. Okay. So let us get into the details. So what is compression of gas? Okay. Compression of gas is a thermodynamic process and can be done in many ways. What are all those? Isobaric, a process wherein pressure remains constant. Isothermal, a process in which there is not change in temperature. Then isentropic, a process when there is no change in entropy. And of course, adiabatic process, a process during which there is no external change of heat. So this is just about the basics, compression of gas methodologies. So now let us get into the details. What is the purpose of using a compressor? Of course, compressors are the machine required for transportation, movement of gases in a system, right? So the purpose of compression is to simply increase the pressure of a gas from one level to another. That's it. So depending on the host of circumstances, situation, the pressure increase imparted to a gas will be from a fraction of a bar in laboratory equipment to literally tens of hundreds of bars, as in hypercompressor. So here you may ask, what is this hypercompressor? Hypercompressor is a high pressure reciprocating compressor primarily used in the low density polyethylene plants actually. So these compressors are designed to handle extremely high pressure, often reaching up to 3500 bar, equivalent to 50,000 psi for compressing the ethylene. So this is just an intro that the purpose. Okay, now let us get into more details. Method of compression. Okay, so one is dynamic, yes, and another is a positive displacement. So in dynamic type of compressor are machines in which gas is compressed by the dynamic action of the rotating vanes or impellers, imparting velocity to flowing gas. And of course, under dynamic, we have a centrifugal and axial, which we will talk later. Okay. And of course, here the velocity head is converted into pressure. So that is the point. Velocity head. Okay. Then we have a positive displacement. Here, in this method, is to trap the volume of gas and displace it by positive action of a piston or rotating member and are known as positive displacement compressor. Okay. And of course, under positive, we have a reciprocating and rotary. Okay. So this is the skeleton, dynamic and positive displacement. I hope these basics are clear. Now let us get into the compressors details. So compressors detail in the sense, okay, uh, positive displacement. Okay. So of course, compression fluid by reducing volume of compression chamber. Okay. So a positive displacement compressor works by drawing air or gas into the chamber and then reducing the volume of that chamber to compress the gas. That is the point here. Okay, friends. So under positive displacement, we have a reciprocating piston compressor and we have a rotary screw compressor. And yeah, there are many more rotary vane compressor and scroll compressor, diaphragm compressor. But now here we'll focus on reciprocating and rotary screw. Okay, rotary type. And of course, under rotary, there are many types are there. Let us limit our discussion to this reciprocating. So reciprocating piston compressor, it uses piston driven by the crankshaft to compress the gas. Very simple. It uses the piston driven by the crankshaft to compress the gas. Then we have a rotary. Okay. So this gentleman uses two interlocking helical screws to compress the gas. Okay. So under rotary, this I told you, right, screw, right? Yeah, helical screw. So under the screw compressor, we have a oil free and oil injected. Okay, right. So yes, screw compressor. Yeah, again, as I mentioned, it is a type of positive displacement. Okay, compressor that uses two interlocking helical rotors, that is screws to compress the gas. Okay, so that is the point. Now we have actually two types: oil-free and injected. Right, oil injected. Okay, so what is this oil-free? In oil-free, there is no use of oil actually, right? So it does not, it will not use oil in the compression chamber, making them suitable for what? Application requiring clean air. Okay. Then what is this oil injected? Okay. Oil injected, basically this use oil to lubricate the rotors, which help in sealing and cooling. Okay. So this is about the short intro. Of course, yeah, this oil free is dry and liquid injected, and this oil injected is used for medium pressure and high pressure. Medium pressure in the sense air and gas, high pressure in the sense gas and refrigeration. Okay, so we covered this positive displacement. Okay, now we go into the dynamic type. Okay, so dynamic type, basically, as I mentioned, it's like a type of continuous flow compressor that uses high speed rotating elements to increase the velocity of gas, which is then converted into pressure, right? So again, I repeat. So the dynamic compressor, or a type of compressor, continuous flow compressor that uses high speed rotating element, okay, to increase the velocity, okay, of a gas, which is then converted into pressure. Okay, so again, this is divided into centrifugal and axial. Okay, so centrifugal, basically centrifugal use actually a rotating impeller to add velocity to the gas, which is then converted into pressure. Okay, and when we talk about the axial compressor, so it's basically, compress gas by accelerating it axially through a series of rotating and stationary blades. So that is the, basic concept, friends. Okay. Of course, we are going to talk about this axial, all other types in detail in the subsequent sessions based on your interest. Okay. I've actually prepared a video on this axial in detail. And of course, you want centrifugal and other types also, I'll willing to upload. You can comment. Now, let us go into the ranges of application to wind up this session. Okay. So positive displacement machines is, application is below 3000 meter cube per hour. Okay. So in the positive, you will get all these reciprocating all comes under positive. Let's just go behind. You see here positive, under that reciprocating rotary. Dynamic, you have a centrifugal and axial. So in this graph, the reciprocating is positive displacement. So positive displacement machine is used below 3000 meter cube per hour. Okay. So it comes under here in this region. Okay. Then axial compressors above 30,000. Okay. So if you talk about axial means this is again dynamic. So it comes here actually, axial. Then flow region between 3000 to 12,000 is usually overlapping between positive displacement, that is reciprocating, and a centrifugal compressor. So centrifugal, what is that? Again, go back here. Centrifugal is dynamic, right? Yes. So for a flow region between 3000 to 12,000 is usually overlapping between positive displacement, that is reciprocating, and centrifugal. Okay. So this is in this region. Then flow region between 30,000 to 12,000 is usually overlap between centrifugal and axial. So that is how it's used. This is basically a range of application. So what type of application, or what range you can use, what type of compressor. So that is the point here. So with this, I will wind up this basic session. Then next, I will talk about more on the turbine with a beautiful, simple explanation, and followed by the axial compressor in detail. Thank you. And again, I request all of you to show your support, uh, whichever way you feel. Okay? Right. Thank you. Bye bye.